Video problem 83, the pH scale. Determine the pH of the following strong bases. So again, strong bases, they're going to break up completely. So here if we're throwing, now let's make it aqueous. If we're talking about sodium hydroxide, it's going to break up into the sodium ion and the hydroxide ion. So if this is 0.004, then this is also 0.004. Right? But since we're dealing with bases here, we're not calculating the pH at first, we're calculating the pOH. So what I'm going to do is I'm going to calculate the pOH, and then I'm going to subtract that from 14. So this is the negative log of 0.004. So I get a pOH equal to 2.398. Then I'm going to take pH plus pOH, set that equal to 14. So it's pH plus 2.398 is equal to 14. So I'm going to subtract 2.398 from both sides. So I get an answer of, here's my calculator answer, 11.60. But I'm going to round that to one significant figure. So the pH is going to be equal to 12.0. I guess it'd be 11.6, wouldn't it? Yeah, it should be 11.6 because those don't count towards sig figs. Let's look at the next one, calcium hydroxide. Now the difference here is that when that calcium hydroxide breaks up, it's going to break up into the calcium ion in two hydroxides. So if this is 1.25 times 10 to the negative fourth, this value is 2.5 times 10 to the negative fourth because it's a 1 to 2 ratio. Again, I'm calculating pOH, negative log of 1.25 times 10 to the negative fourth. So I get a value of 3 sig figs for my, this is pOH, so I'm going to keep all the numbers. 3.903, and then I'm going to take pH plus pOH is equal to 14. So I get a value of, for 3 sig figs for my pH, 10, I want 3 sig figs, 0.097. 4 grams of potassium hydroxide. Potassium hydroxide looks like this. If I have 4 grams of it, I need to convert that to moles first. Let's put the potassium hydroxide in the thing here. There we go. Grams on bottom, moles on top. That's molar mass, of course. So potassium is 39.1, oxygen is 16, and hydrogen is 1.008. And again, show that work. So I get 56.108. That's how many grams per mole. So 4 divided by that value is going to give me 0.0713 moles. Okay. And then I'm going to divide that by 1 liter. So I'm still going to take pOH, negative log of the hydroxide. Notice how I show the equation every time. So it's negative log of 0.0713. So I get a pOH of 1.147, and then pH plus pOH is equal to 14. So 14 minus that value, and I get 12.853. I should have 2 sig figs, so 12.85. So there you go, some pOH calculations.